In this lesson, you will be learning how to use the distributive property. The things that you will be learning in this video are how will you create an equivalent expression showing the GCF of two addends using the distributive property. That sounds pretty complicated, doesn't it? But don't worry, we're going to go through all of this. The other thing that you're going to learn how to do is to do something similar to this example here. For example, how can the distributive property help us to write an equivalent expression using the GCF for 36 plus 8? This is what you're going to be able to do by the end of this lesson. You do not need to write anything on this page. This is simply telling you the objectives for this particular concept. We will be doing these things in later examples. Let's review. Any number can be written as a sum of two or more numbers. All that really means is that every single number that you can think of can be written as a sum of two or more numbers. So for example, you have the number 16 here. That can also be written as 1 plus 15. It could be written as 2 plus 14, 3 plus 13, 4 plus 12, 5 plus 11, 6 plus 10, 7 plus 9, or 8 plus 8. Every single number that we have here in these addition problems is called an addend. Okay? The numbers in an addition problem are called addends. So every single one of them is an addend. When we say that a number can be represented in another way, such as 16 being represented in one of these ways, that is just like thinking of speaking in a different language. I might say hello in English, someone else might say hola in Spanish, or they could say hello in any other language, and it would still mean hello. Same thing here, 16 is still 16 even if you call it 1 plus 15 or 2 plus 14. It's the same thing, it's just another way to express the same number. More review. A factor of a multiplication expression can be rewritten as the sum of two numbers. That just means that if you have a problem such as 6 times 14, you can take the factors and rewrite them as the sum of two numbers. So for example, 6 is a factor. Okay, in this problem we have two factors. 6 is a factor and 14 is a factor. Okay. We can take one of the factors, 14, and we can represent it as 10 plus 4. Okay, same thing. Even more review. We can use parentheses to show part of an expression. So for example, if we have this expression, 6 times 10 plus 4 equals 6 times 14, we can take parentheses and put it around part of the expression to represent one of the factors. It's just a different way to write the problem. Remember, the greatest common factor is the largest factor shared by two numbers. You can find the GCF by listing or using the birthday cake method. So let's try to find the GCF for 9 and 24. Okay. The way that we've taught you how to do this is you can either list your numbers, list all the factors for each number and find the largest one they have in common, or you can go with our recommendation and use the birthday cake method. That always works really well. And that's what I'm going to do here. So let's find the GCF of 9 and 24. Actually, why don't you pause for a moment and in your notes you do this on your own and then come back and I'll show you how to do it. Okay, welcome back. I hope you took the time to actually find the GCF of 9 and 24, and now I will walk you through it so you can see if you were correct. We will look at the numbers 9 and 24 and pick a common factor. Now, you should know that 9 has only a factor of 3, 1, and 9. So I'm going to take 3 and divide it out of both 9 and 24. 3 goes into 9 3 times. 3 goes into 24 8 times. I look at my bottom layer of the cake and I can see that these two numbers do not have anything in common. 3 is a prime number and it is only divisible by 1 and 3, so it does not have any factors in common with 8. So our cake is done. So we know that the side of the cake, those yummy sprinkly part, my favorite part with all that frosting, that is the GCF. There is no numbers to multiply, it's just simply 3. So our GCF for 9 and 24 equals 3. Hopefully that was just a review for you because you already know that. Okay. Now, let's learn about the distributive property. We like to say that we have two ways to do the distributive property, going forward or going backward. The first one that we will be discussing is going forward, okay? So pay attention to both ways because you will be doing both as you work on this concept. The going forward method kind of looks like this is the one you'll be doing. And you will see an example of this. Okay, you may or may not have ever heard of this before. Now, I like to think of the distributive property as numbers or friends, and the people inside the parentheses, they're in the house. Okay, they're having a party. I like to think about 10 and 4. You can see 10 and 4 are hanging out in the house having a party. Now, 6 would really like to hang out with these guys and really wants to go to the party, but he has to ask. Okay, he has to ask 10 and 4 if he can go to the party. The parentheses represent the door to the house. When you have a number next to a parentheses with no sign in between them, that means that it is multiplication. Okay, that's what that means. So, in order for 6 to be able to go to this party, he has to ask 10 and 4 if it's okay. And this is how that looks. You would take 6 and distribute it over both the 10, okay, and the 4. And the way we represent asking the question, can I go to the party, is through a multiplication problem. Because, like I told you before, when you have a number next to parentheses with no sign there, that means you're multiplying. So you would rewrite this as 6 times 10. Okay, that represents 6 talking to 10. You represent it like that. I will put parentheses around it. Okay, and I said that 6 has to also talk to 4 to see if 4 is okay with him going to the party. So you would represent that as 6 times 4. Okay, you must keep in mind that there was a sum here before. There was a sum of 10 plus 4. So we still need to keep our sum, and we need to keep that sign right here. That is an example of the distributive property. And let me show you that it works. I will prove to you that it works. 6 times 10, you should know, is 60. 6 times 4 is 24. 60 plus 24 is 84. Let's see if that's the same as what we have up here. In this problem, we have 6 times 10 plus 4. 10 plus 4 is 14. 6 times 14, let's test it out. 6 times 4 is 24. 6 times 1 is 6, plus 2 is 84. So that is very much true. So this is true. So that's how you use the distributive property to represent numbers in different ways. So look again what I'm showing you. This is one way to express the number 84. This is another way to express the number 84. And this is one more way to express 84. We can also express it like this, 6 times 10 plus 6 times 4. So what you can see here is that we have 1, 2, 3, 4 ways to represent the number 84. Even 5 ways if you look at this number down here. 60 plus 24 is 84. So lots of different ways to say the very same thing. Okay, now I would like you to add an additional page into your notes. We are going to do a couple more examples of going forward with the distributive property. Okay, so one thing I want you to know is that you can also use the distributive property with subtraction. Let's just take a look at what that might look like. Here we have problem, 7 times the difference of 10 minus 3. This looks exactly the same way as we did before. We rewrite this as two problems. One thing I like you to know right away is you take the sign from in between the parentheses and bring it right down. So this would be subtraction instead of addition. And then we do our multiplication. 7 times 10 minus 7 times 3. 7 times 10 is 70, minus 7 times 3 is 21. Okay, 70 minus 21 is 49, which is the same thing as this, which is 7 times 7, which is also 49. Okay, let's do another one. Let's do one now with what we call a variable. Okay, you haven't really learned about variables yet. They come up a lot in Unit 4, but we're going to go ahead and practice because we do use the distributive property with variables. Let's write a problem. 9 times 5a plus 6b. You might be saying, what is the a and what is the b? Those are called variables. What they are symbols that represent something that we don't know. I like to think of them as they just sort of hang out with the numbers that they're with, the 5 and the 6. You simply just need to know how to use your distributive property, and you can handle this. You write your two parentheses, the plus sign comes down, 9 times 5a plus 9 times 6b. It's as simple as that. In this case, the farthest you can go with simplifying is do 9 times 5 is 45. Keep your a, it travels with the 5, and then 9 times 6b would be 54b. Now we have to stop at this point because a and b are two different things. We cannot combine them. Okay? That should be enough examples of going forward. After this video, you will be going into video 2 and working on going backward with the distributive property. Okay? Please come back to this video and review these examples if you're struggling in your practice. Okay, I'm going to add a question now for you to answer just to see how you're doing. Please answer the question above and see how you did. Show your teacher when you finished which answer you chose.